Hello, my dear students. Welcome to Teacher at Home. Today class we are going to learn the 8th chapter that is about force and pressure. In class 7 you have learned how objects move. സാധനങ്ങൾ എങ്ങനെയാണ് നീങ്ങുന്നതെന്ന് നമ്മൾ പഠിച്ചതാണ്. Do you recall how we can decide whether an object is moving faster than another? What does the distance moved by an object in unit time indicate? We also know that a moving object like a ball rolling on the ground slows down. Sometimes it may change its direction of motion. It is also possible that the ball may slow down and also change its direction. Have you ever wondered what makes an object slow down or go faster or change its direction of motion? Let us recall some of our everyday experience. What do you do to make a football move? What do you do to make a moving ball move faster? How does a goalkeeper stop a ball? A hockey player changes the direction of the moving ball with a flick of the stick. How do fielders stop a ball hit by the batsman? In all these situations, the ball is either made to move faster or slower, or its direction of motion is changed. We often say that a force has been applied on a ball when it is kicked, pushed, thrown, or flicked. What is a force? What can it do to bodies on which it is applied? We shall see answers to such questions in this chapter. Force, a push or a pull. Actions like picking, opening, shutting, kicking, hitting, lifting, flicking, pushing, pulling are often used to describe certain tasks. നമ്മൾ എന്തെങ്കിലും ചെയ്യുന്ന പ്രവൃത്തിയെ ഡിസ്ക്രൈബ് ചെയ്യാനാണ് പിക്കിംഗ് അപ്പ് എടുക്കുക, ഓപ്പണിംഗ് തുറക്കുക, ഷട്ടിംഗ് അടയ്ക്കുക, കിക്ക് തള്ളുക, ഹിറ്റിംഗ്. Okay. Each of these actions usually results in some kind of change in the state of motion of an object. Can these terms be replaced with one or more terms? Let us find out. Do you notice that each of the actions can be grouped a pull or a push or both? Can we infer from this that to move an object, it has to be pushed or pulled? In science, a push or a pull or an object, it is called a force. Thus, we say that the motion imparted to objects was due to the action of a force. When does a force come into play? Let us find out. Forces are due to an interaction. Suppose a man is standing behind a stationary car. Will the car move due to his presence? No. Suppose the man now begins to push the car. തള്ളുകയാണ്. That is, he applies a force. അപ്പോൾ ഒരു ബലം ഉപയോഗിക്കുന്നു. The car may begin to move in the direction of the applied force. ഏത് ഭാഗത്തേക്കാണോ തള്ളുന്നത് ആ ഭാഗത്തേക്ക് അത് നീങ്ങിത്തുടങ്ങും. Not the man had to push the car to make it move. അല്ലേ, തള്ളിയാൽ മാത്രമേ അത് നീങ്ങുള്ളൂ. Shows 3 situations that may be familiar to you. Can you decide who is pulling and who is pushing in these cases? Both the girls appear to push each other, while the pair of girls in 8.3b are trying to pull each other. Similarly, the cow and the man appear to pull each other. The girls in the two situations shown here are applying the force on each other. Is it also true for the man and the cow? From these examples, we can infer that at least two objects must interact for a force to come into play. രണ്ട് വസ്തുക്കൾ ഉണ്ടായാൽ മാത്രമേ എന്താണ് ഒരു ഫോഴ്സ് അപ്ലൈ ചെയ്യേണ്ട ആവശ്യം വരുള്ളൂ. Thus an interaction of one object with another object results in a force between the two objects. Exploring the force. Let us try to learn more about forces. Choose a heavy object like a table or a box, which you can move only by pushing hard. Try to push it all by yourself. Can you move it? അതിന് നീക്കാൻ പറ്റുമോ? Now ask one of your friends to help you in pushing it in the same direction. ഒരു ഫ്രണ്ടിനോട് എന്താ ചോദിക്കേണ്ടത്? ഒരേ ഡയറക്ഷനിലേക്ക് പുഷ് ചെയ്യാൻ വേണ്ടി ഹെൽപ്പ് ചെയ്യാൻ. Is it easier to move it now? ഓ, മൂവ് ചെയ്യാൻ എളുപ്പമാണോ? Can you explain why? Now push the same object. Now ask your friend to push it from the opposite side. വേറൊരു ഭാഗത്ത് നിന്ന് പുഷ് ചെയ്യാൻ അവനോട് പറയുക. Does object move? അത് നീങ്ങുമോ? If it does, note the direction in which it moves. അങ്ങനെയാണെങ്കിൽ ഏത് ഡയറക്ഷനിലാണ് എന്ന് നോക്കുക. Can you guess which one of you is applying larger force? ഏതാണ് കൂടുതൽ ഫോഴ്സ് അപ്ലൈ ചെയ്യണത് എന്ന് നോക്കാം അല്ലേ ഇതിന്റെ സെയിം ഡയറക്ഷൻ, ദിസ് വൺ ഇൻ ദ ഓപ്പോസിറ്റ് ഡയറക്ഷൻ. Have you ever seen a game of tug of war? In this game, two teams pull at a rope in a രണ്ട് ടീംസ് ഏത് ഡയറക്ഷൻ ഓപ്പോസിറ്റ് ഡയറക്ഷനിലാണ് പുൾ ചെയ്യുക. Members of both the teams try to pull the rope in their direction. Sometimes the rope simply does not move. Is it not similar to the situation shown? The team that pulls harder, that is applies a larger force, finally wins the game. What do these examples suggest about the nature of the force? Forces applied on an object in the same direction add to one another. Now recall what happened when you and your friend push the heavy box in the same direction. It will move easily. If the two forces act in the opposite direction of an object, the net force acting on it is it the difference between the two forces. What do you observe in activity? When both of you were pushing the heavy box from opposite direction. Recall that in the tug of war, when two teams pull equally hard, the rope does not move in any direction. So, we learned that a force could be larger or smaller than the other or equal to each other. The strength of the force is equally usually expressed by its magnitude. We have also to specify the direction in which a force acts. Also, if the direction of the magnitude of the applied force changes, its effect also changes. A force can change the state of motion. തള്ളുമ്പോൾ തന്നെ അതിൻ്റെ ചലനം വ്യത്യസ്തപ്പെടാം. Let us now find out what happens when a force acts on an object. Take a rubber ball and place it on a level surface such as a tabletop or a concrete floor. റബ്ബർ ബോൾ എടുത്തിട്ട് നമ്മളിവിടെ സർഫസ് ലെവലായിട്ടുള്ള ഒരു ഏരിയയിൽ വെക്കുകയാണ് അല്ലേ. Now gently push the ball along the level surface. Does the ball begin to move? അപ്പോൾ നമ്മളൊന്ന് തള്ളിയാൽ അത് നീങ്ങാൻ തുടങ്ങുമോ? Push the ball again when it is still moving. അപ്പോൾ അതിനൊന്നും കൂടെ നീക്കുകയാണ് അല്ലേ നമ്മൾ. Is there any change in the speed? Does it increase or decrease? Next, place your palm in front of the moving ball. Remove your palm as soon as the moving ball touches it. Does your palm apply a force on the ball? What happens to the speed of the ball now? Does it increase or decrease? What would happen if you let your palm hold the moving ball? It will stop. You might recall similar situations. For example, while taking a penalty kick in football, the player applies a force on the ball. Before being hit, the ball was at rest, so its speed was 0. Applied force makes the ball move towards the goal. Suppose the goalkeeper dives or jumps to save the goal. By this action, the goalkeeper tries to apply a force on the moving ball. Force applied by him can stop or deflect the ball, saving a goal being scored. If the goalkeeper succeeds in stopping the ball, its speed decreases to 0. These observations suggest that a force applied on an object may change its speed. നമ്മളൊരു ഫോഴ്സ് അപ്ലൈ ചെയ്യുമ്പോൾ അതിൻ്റെ സ്പീഡിൽ മാറ്റം വരും. If the force applied on object is in the direction of its motion, speed of the object increases. If the force is applied in the direction opposite to the direction of motion, results in the decrease in the speed of the object. I have seen children competing with one another in moving a rubber tire or a ring by pushing it. I now understand why the speed of the tire increases when it is pushed. Paheli is curious to know whether the application of a force can only change the speed of an object. Let us find out. Take a ball and place it on a level surface as you did in the activity 8.3. Make the ball move by giving it a push. Now place a ruler in its path. In doing so, you would apply a force on the moving ball. Does the ball continue to move in the same direction after it strikes the ruler? Repeat the activity and try to obstruct the moving ball by placing the ruler in such a way that it makes different angles to its path. In each case, note your observation about the direction of motion of a ball after it strikes the ruler. ഓക്കെ, അതായത് നമ്മളൊരു സ്കെയിൽ വെച്ചിട്ട് തടുക്കുമ്പോൾ അത് പല ആംഗിൾസിലായിട്ട് മൂവ്മെന്റ് ഉണ്ടാവും. അതാണ് ഇതിൽ പറഞ്ഞിരിക്കുന്നത്. Let us consider some more examples. In a game or volleyball, players often push the moving ball to their teammates to make a winning move. Sometimes the ball is returned to the other side of the court by pushing or smashing it. In cricket, a batsman plays his or her shot by applying a force on the ball with the bat. Is there any change in the direction of motion of the ball in these cases? In all these examples, the speed and the direction of the moving ball change due to the application of a force. Can you give a few more examples of this kind? A change in either the speed of an object or its direction of motion, or both, is described as change in its state of motion. Thus, a force may bring a change in the state of motion of an object. State of motion. The state of motion of an object is described by its speed and the direction of motion. State of rest is considered to be the state of zero speed. An object may be at rest or in motion. Both are in the state of motion. Doesn't mean that the application of force would always result in the change in the state of motion of the object. Let us find out. It is common experience that many of time, application of force does not result in a change in the state of motion. For example, heavy box may not move at all even if you apply the maximum force that you can exert. Again, no effect of force is observed when you try to push a wall. Force can change the shape of an object. Some situations in column 1 in which objects are not free to move, such as the manner in which force can be applied on each object. Try to observe the effect of force has many situations. എന്തൊക്കെയാണ്? Lump of dough on a plate, pressing it down with your hands. Lump of dough means മാവ് നമ്മൾ കുഴയ്ക്കുകയാണ്. Spring fixed on a seat of a bicycle by sitting on the seat. Then the rubber band suspended from a hook. A plastic or metal scale placed between two bricks. ഒരു പ്ലാസ്റ്റിക് രണ്ട് കല്ലിയുടെ ഇടയിൽ വെച്ചിരിക്കുകയാണ്. What do you conclude from the observation noted in table 8.2? What do you conclude from the observations? What happens when you apply a force on an inflated balloon by pressing it between your palms? What happened to the shape of a ball of dough when it is rolled to make a chapati? What happens when you press a rubber ball placed on a table? In all these examples, you saw that the application of force of an object may change its shape. Having performed all the above activities, you would have realized that a force may make an object move from rest, may change the speed of an object if it is moving, may change the direction of motion of an object, may bring about a change in the shape of an object, may cause some or all of these effects. While a force may cause one or more of its effects, it is important to remember that none of the actions can take place without the action of a force. Thus, an object cannot move by itself. It cannot change speed by itself, cannot change direction by itself, and its shape cannot change by itself. Contact forces. Muscular force. Can you push or lift a book lying on a table without touching it? Can you lift a bucket of water without holding it? അതായത് കൈ തൊടാതെ നമുക്ക് ബുക്ക് അനക്കാൻ പറ്റുമോ? അതുപോലെ എന്താണ് ഒരു ബക്കറ്റ് അതിനെ പിടിക്കാതെ നമുക്ക് എടുക്കാൻ പറ്റുമോ? Generally, to apply force with an object, your body has to be in contact with നമ്മുടെ ബോഡി എപ്പോഴും എന്തിലായിട്ട് കോണ്ടാക്ട് ചെയ്യണം? ആ ഒബ്ജക്റ്റുമായിട്ട് കോണ്ടാക്ട് ആയിരിക്കണം. This contact may also be with the help of a stick or a piece of rope. When we push an object like a school bag or lift a bucket of water, where does the force come from? This force is caused by the action of muscles in our body. The force resulting due to the action of muscles. മസിൽസിന്റെ ആക്ഷനിലൂടെയാണ് ആ ഫോഴ്സ് ഡെവലപ്പ് ആവുന്നത്. അതിനെയാണ് മസ്കുലർ ഫോഴ്സ് എന്ന് പറയുക. It is the muscular force that enables us to perform all activities involving movement or bending of our body. In class 7, you have learned that in the process of digestion, food gets pushed through the alimentary canal. Could it be a muscular force that does it? You also know the lungs expand and contract while we inhale and exhale during breathing. Where are these muscles located which make breathing possible? Can you list a few examples? Animals also make use of muscular force to carry out the physical activities and other tasks. Animals like bullocks, horses, donkeys, camels are used to perform various tasks for us. Performing the tasks, they use muscular force. Since muscular force can be applied only when it is in contact with an object, it is also called a contact force. Are there other types of contact force? Let us find out. So that's all about this first part. The next part we can see in part 2. If you are interested, please do like, share and subscribe my channel. Okay, thank you.